Hello student, we start a new article from Web Optics and it is Brewsters Law. Now what is Brewsters Law? So that we have to start. So I consider here transparent medium, glass. You can see in a diagram air, glass. Then I consider ordinary light. Ordinary light means unpolarized light I am considering. Is incident on this transparent medium glass. Then it partially reflect and partially refract. So I consider this I is angle of incidence. So part of light is reflected. You can see a reflected light. While rest is refracted. You can see a refracted light also. So this is a reflected and this is a refracted light. Then experimentally it is observed that at certain angle of incidence, that angle of incidence is called as polarizing angle. The reflected light is completely polarized. In this light, reflected light is polarized. This light is completely polarized. So you can see in a diagram, we shown only one vibration to this reflected light, only by dotted. So this is polarized light. And refracted light is partially polarized or unpolarized. So you can see here both the vibration, horizontal as well as vertical vibration, both the vibration we shown. Sometime it may be a particular vibration, maybe it is partially polarized. So it is partially polarized. Now here new concept is introduced and it is polarizing angle. Now what is polarizing angle? Polarizing angle is a such angle of incidence. So when this reflected light is completely polarized, that angle of incidence is called as polarizing angle. Angle of polarization or polarizing angle. You can see here in a diagram. So this is polarizing angle. So experimentally it is found that when light is incident at a polarizing angle, then reflected and refracted rays are mutually perpendicular. This is a very important conclusion. So when this angle is polarizing angle, that time reflected and refracted rays are perpendicular to each other. So you can see here a 90-degree angle between these two, reflected and refracted light. And this concept we have to use in proof of Brewster's law. Basically, statement for the Brewster's law is tangent of this polarizing angle. If you find out this tangent of this polarizing angle, that tangent of polarizing angle is equal to refractive index. Now let me prove this Brewster's law. So proof of Brewster's law. Now what we have to prove? Tangent of this polarizing angle is equal to refractive index. Now for that we consider again a diagram. This is unpolarized light, okay, incident light. Then when it is reflected, it is plane polarized. So this angle is polarizing angle. This is angle reflected, refracted angle. And reflected and refracted rays are perpendicular to each other. According to Snell's law, so you know that Snell's law, sin I upon sin R is the Snell's law. Now here, you can remember one thing here. From figure, we can know that this R dash we shown as an angle of reflection plus 90 plus this angle of refraction, it is coming 180. So by using that, I can write R dash plus R is equal to 90. 180 minus 90 we can do. Then by using that angle of refraction, we can write 90 minus R dash. R dash is angle of reflection. So you know that angle of reflection and angle of incidence both are same. So I can write 90 minus IP is R. So this R we have to substitute in Snell's law. Hence, refractive index is equal to sine of IP divided by sine of, instead of R, 90 minus IP we can write. Now, remaining step I can write it here. Now, next one. Refractive index is equal to sine IP divided by sine 90 minus IP is cos IP. Sine IP divided by cos IP is tan of IP. So refractive index is equal to tan of IP. Hence, proved. If question is asked through Brewsters law, then that much you have to write. Statement tangent of polarizing angle is equal to refractive index of the transparent medium at which partial reflection and refraction occur.